record on this computer. Fine. I think now the class is getting recorded.
Yes, sir.
Yes, sir.
Okay. So actually, up to this, we were studying about the charging phase of the capacitor. But I told you that a capacitor has basically two phases. One is charging phase, another one is discharging phase. Okay. Now today we will study about the discharging phase of a capacitor. Fine. If we want to discharge a capacitor, it is very simple to understand that at first we have to charge it, right? At first we have to charge the capacitor, then only can we discharge the capacitor, isn't it? If we haven't charged the capacitor, then how can we discharge it, right?
Yes, sir.
Fine. So it is a very simple understanding, right? If we want to discharge any capacitor, that capacitor must be charged first. Okay. And in order to explain the charging phase of a capacitor, I had drawn a circuit. Okay, RC circuit, right? And the circuit looked like this. This was my plate 1, this was plate 2, right? And we had two contacts or two positions in the circuit. This was position 2 and this was position 1. Can you recall the circuit? The circuit was this, right? And the capacitance of this capacitor was what? C. Fine. And it was connected to the ground, right?
Yes, sir.
And in order to charge this capacitor, we moved this switch. Suppose this switch is S. Okay, we moved this switch into position 1, right?
Yes, sir.
Okay. Now
Yes, sir.
suppose we want to move this switch into position 2. Okay, and if we move this switch S into position 2, then how will the circuit look? We will move this switch to
short
this
circuit
position,
hobe pashe
to this position, right? We will move this switch S to position 2.
Yes, sir.
From the position 1. Okay, then actually this portion of the circuit or this portion of the network will be open, isn't it?
yes sir, open circuit hobe.
Okay, this portion of the network will be considered as open circuit. Fine. That means and what is in this portion? The power supply or the voltage source, right? That means the voltage source will be removed from this portion of the network, isn't it? This voltage source will have no effect on this portion of the network, isn't
Yes, sir.
it?
Yes,
Fine?
sir.
Okay. And suppose that we have charged our capacitor completely. Okay. If we have charged our capacitor okay, then let me erase this portion of the network at first, because this portion has no effect now. Okay, so we can erase it, and it is connected to the ground. And now suppose we have completely charged our capacitor. So if we have charged our capacitor completely, then of course the charge stored on this capacitor will be maximum, isn't it?
Yes, sir.
And in the previous class we denoted the maximum charge on the capacitor by Q naught, right?
Yes, sir.
Yes, sir.
Okay, Q naught. So plate 1 was positively charged, isn't it?
Yes, sir.
And plate 2 was negatively charged, right? And how much charge is on plate 1? It is Q naught amount of
Q
charge.
naught.
Okay, positively charged Q naught. Okay, and how much amount of charge is in the plate 2?
Q naught.
Minus
Q naught.
minus Q
Minus
naught.
Q
Okay,
naught.
so the total charge stored on this capacitor is Q naught. Fine, and we also know that Q naught equals CE, isn't it?
Yes, sir.
Q naught equals C. What is E here?
So voltage source আগে যেটা বাদ
Sir,
দিয়ে
applied voltage. Applied
E-
voltage.
E can be defined in two ways. E is the voltage of the power supply or applied voltage, or E is the maximum voltage across the capacitor,
Yes, sir.
isn't it? And if we have charged our capacitor completely, that means the capacitor has achieved its steady state condition, right? And under
Yes.
steady state condition, the capacitor voltage equals the applied voltage. We know it. Fine. Okay.
Yes,
So
sir.
Q naught equals C. Fine. Okay, and let us count our time from 0 second. Okay, so at t equals 0, what will happen? Okay, at t equals 0, what will happen? Let us analyze that. That means at t equals 0, what will be the current through this circuit? Okay, at t equals to 0, what will be the voltage across this capacitor? Fine, we'll analyze that. We actually start counting our time from 0th second. Okay, so at when the time is 0, then what will be the voltage across this capacitor? The voltage is maximum, it is E, isn't it?
yes sir
Right, or it can also be written as Vc equals to Q naught upon C, isn't it?
yes sir
Yes, sir.
When Vc will equal E or applied voltage, right? When the time is 0, then Vc will be equals to E, right? And what would be the voltage at this point? It is 0 volt, isn't it? Right, then what will be the voltage at this point? Again, it will be 0 volt, isn't it?
Yes, sir.
Fine. Okay, then what would be the voltage at this point?
Sir, Q naught by C.
It is Q naught by C, because the voltage across this capacitor is Q naught by C. So if we want to calculate the voltage at this node, then we have to start our journey from this node. Then 0 plus Q naught by C equals to Q naught by C. Okay, Q naught by C. And what is the voltage at this point? It is
0 volt.
0 volt.
It is 0 volt, right? Okay,
Yes, sir.
it will be 0 volt. Now, what would be the potential difference across resistor R?
sir Q naught by C
Q naught by C, right?
Q naught by C.
Q naught by C. Then what would be the current through this circuit? It is at time t, this will be our initial current, right? I naught will equals what? The potential difference across resistor R upon R, right? So it will be what? Q naught by C upon R, isn't it? Fine. Okay, then if we simplify this, RC, Q naught equals to CE or RC, right? C and C will cancel each other, then it would be equals to what? RE by R. Okay, it can also be explained in another way. And what is that? Actually, the voltage across this capacitor is E, isn't it? And the capacitor and this resistor are connected in parallel, right? And we know that parallel branches have the same voltage across them, isn't it? Okay, fine. So I naught is actually the initial current. I naught is the current at time t equals to 0, right?
Yes,
Fine.
sir.
Then now, what is the voltage? What is the voltage? V naught equals to E. The voltage across the capacitor is V naught. and it equals E. Okay. Now what will happen when T is greater than 0? Then what will happen?
Sir, voltage
now,
কমবে।
now this capacitor has voltage, right? This capacitor has two plates, plate 1 and plate 2. Plate 1 is positively charged and plate 2 is negatively charged, right? Then when the time will be greater than 0, the negative charge or electron on plate 2 will be attracted towards the positive charge on plate 2, isn't it? Because we always know that negative charge gets attracted towards the positive charge. Fine. So these negative charge or electrons
Yes.
from this plate 2 will get attracted to the positive charge of plate 1. Fine. That means these electrons or these negative charge will start transferring from plate 2 to plate 1, isn't it? Okay. And that means electron will be transferring from plate 2 to plate 1. Okay. And when an electron will reach plate 1, then one electron and one positive charge, one negative charge and one positive charge will cancel each other, isn't it?
Yes, sir.
Right? Okay.
Yes, sir.
Will cancel each other. Fine. Then after a long time, okay, after a long time, that means when t equals to infinity, sorry, when t equals to infinity, that means after a long time, what will happen? All the negative charge will be transferred from plate 2 to plate 1, isn't it? And all
Yes,
those
sir.
negative charges will cancel all the positive charges on plate 1, isn't it? It means there will be no negative charge on plate 2 and there will be no positive charge on plate 1, isn't it?
Yes, sir.
Right? After a long time, maybe that time is infinity. Okay. So after a long time, all the negative charge will be transferred to plate 1 and they will cancel all the positive charges. That means after a long time, there will be no negative charge on plate 2 and there will be no positive charge on plate 1. So it means both plate 1 and plate 2 will be neutral, isn't it? If there is no charge, that means that metal is what? Neutral. No charge means neutral, right? Okay. And if there is no charge, then what will be the voltage?
Yes, sir.
No voltage, right?
0, sir.
0 voltage.
Because we know from this equation V is equals to Q naught upon C, okay, or simply V equals to Q upon C. If Q is 0, V will be 0. It is very easy to understand, right? So that means we can say that the capacitor has reached its final state or steady state, isn't it? Steady state or final state means the state in which no quantity changes. Fine. Under steady state or final state, no quantity. Quantity means current, voltage. They do not change over time. Fine. So after a long time, that means when t will equal infinity, that time there will be no charge on these capacitor plates. That means there will be no voltage across these capacitor plates. It means there will be no current flowing through this circuit, isn't it? Right? Okay. And this state or this condition is known as the final state of the capacitor or steady state of the capacitor. Okay. So we can write it under steady state. Under steady state, the voltage across the capacitor is equals to what? 0 volt. The charge across the capacitor Q C equals to what? 0 coulomb. The current through the capacitor or through this circuit IC equals to what? 0 ampere, isn't it? Right?
Yes, sir.
Okay. And we can say that because under steady state condition there is no current flowing through this circuit or through the capacitor, it means during the discharging phase of the capacitor under steady state condition, okay, under steady state, the capacitor will act as an open circuit, isn't it? We
Yes, sir.
already know from the previous classes discussion that during the charging phase of a capacitor, there are three states: initial state, transient state, and steady state. And under steady state condition, during the charging phase, capacitor acts like an open circuit. Even it is true for the discharging phase of the capacitor. Under steady state condition, the capacitor will act like an open circuit. Fine. So we can say under steady state condition, the capacitor will act as an open circuit, whether it is in discharging phase or charging phase of the capacitor, isn't it? Right? And we also told that when in initial state, that means when the time will be 0, at that time capacitor acts like a short circuit during the charging phase of that capacitor. Fine. Okay, let us analyze whether that statement holds true here also. Look, from this discussion, it is observable, right, that over time the current through this circuit or current through the capacitor has decreased, isn't it? Initially the current was I0, it is E upon R, but finally the current is 0. That means the current has decreased from its initial value to the final value, isn't it? So it means the current will be maximum when the time will be 0, isn't it?
Yes, sir.
Right? Okay. That means the capacitor let the maximum current flow through this circuit when the time is 0 or in the initial state. So any electrical quantity that lets current to flow to its maximum value, of course, that is the property of what? Short circuit, isn't it? Short circuit gives no resistance to the current. That means the maximum amount of current can flow through the short circuit, right? So we can also say that capacitor acts like a short circuit in its initial state or when the time is 0, t equals to 0. Fine. Okay. So you should note these statements, okay, that capacitor will act like an open circuit under steady state condition during the charging phase of the capacitor, discharging phase of the capacitor. Even in charging phase it is true. And capacitor will act as a short circuit during both charging and discharging phase of that capacitor. Okay. Now the question is, what happens between the initial state and steady state? That means what happens between when the time is greater than 0 and less than infinity. Okay, we'll analyze that. What happens between initial state and steady state? Okay, and in order to do that, at first let me erase this. Do you have any confusion?
No, sir.
No confusion. সবাই ক্লাসে আছো তো?
Yes, sir.
Yes, sir.
ক্লাসে
Yes, sir.
থাকো, হ্যাঁ, আর যদি কেউ না থাকো তাহলে আমাকে জানায় যাও, স্যার চলে যাইতেছি। Okay, I forgot to mention one thing, that can you tell me the direction of current through this circuit?
Anti-clockwise, sir.
চার্জিং ফেজে স্যার যেটা ছিল এর অপোজিট হবে।
The direction would be this, anti-clockwise. Why? Because we know the direction, the conventional direction of current is opposite to the direction of electron, right? Because the electron is flowing from plate 2 to plate 1, that means current will flow from plate 1 to plate 2. Okay, and the direction of current during the discharging phase is opposite to the direction of current in the charging phase, isn't it? In the charging phase, the direction of current was in clockwise, isn't it? But in discharging phase, the direction is opposite, anti-clockwise or counterclockwise. Okay.
Yes,
Now
sir.
we are going to analyze what happens between initial state and steady state. Between initial state and steady state, there is another state known as transient state. Okay, and transient state begins when transient state. Okay, and transient state begins when time is greater than 0 and less than infinity. Fine. Now, actually, when the time will be greater than 0, then charge starts transferring from negative charge, starts transferring from plate 2 to plate 1. Okay, and the amount of charge, the amount of negative charge that can be transferred from plate 2 to plate 1 per unit time is known as the charge transfer rate. Okay, that means charge transfer rate can be denoted by dq by dt, isn't it? dq means
Change
dq
of
by dt. Okay, fine. The amount of charge transferred from plate 2 to plate 1 per unit time is known as the transfer rate of the negative charge, or the rate of transfer of negative charge. Fine. Now my question is, will this rate always be equal?
no, sir.
No.
Will charge always move from plate 2 to plate 1 in equal rate?
No, sir.
The answer is no. Why? It can be explained in a number of ways. First of all, in the beginning, okay, the potential or the voltage across the capacitor was maximum, but we have seen that
Yes.
from the initial state to the steady state, the potential becomes 0. That means the potential has decreased, isn't it? So because over time the potential across the capacitor decreases, of course the rate of transfer of charge will also decrease, isn't it?
Yes, sir.
Right? This is
Yes, sir.
one of the explanations that can be given. There could be another explanation also. Okay, I can also give you another explanation, but I actually do not want to waste time. Fine. Okay, now, so it is clear that the charging rate, the charge transfer rate will always not be same. Okay, and dq by dt will be a negative value or positive value? Can you tell me?
স্যার এবার
dq
নেগেটিভ হবে।
Negative.
in the charging phase, dq by dt was positive value, but in the discharging phase, will it be positive value? The
No,
answer
sir.
is no. Why?
No, sir.
Because the charge is getting reduced over time, isn't it? So
Yes, sir.
at time, sorry, what I am doing. So at t equals to 2 seconds, the charge might be 10 coulomb. T equals to 4 seconds, the charge will get reduced over time, right? Suppose it is 6 coulomb. So if you take the difference of these two, then what will you get? Negative value. But if you take the difference of these 2 times, it will be positive value. Okay, in the numerator it will be negative value, in the denominator it will be positive value. So of course the total value will be negative. Fine. And we know that this can be referred to as the current of the circuit at any time instant t, isn't it?
Yes, sir.
The rate of change of charge with respect to time over time is known as what? Current, right? I equals to q by t, isn't it?
Yes, sir.
So we can write it is the current through the circuit at time t, and this current through the circuit will change over time, isn't it? Because the charge transfer rate will change, so of course the current will also change, isn't it? Right? So between initial state and steady state, we'll get different values of current in different times, isn't it? Is it clear, or do you have any
Yes,
confusion?
sir.
Yes, sir.
Because between initial state and steady state, charge is getting transferred in different rates. So of course current will also be different in different time, right? So suppose this is the current at a particular time t. Okay, this is the current at a particular time t. T can have any value, okay, which is greater than 0 and less than infinity. Fine. So we can write it as a function of t, because I will change with time. Okay. Now let us assume that okay, another thing that we know that current can't have negative value, isn't it? Current cannot have negative value, right?
Yes,
Yes,
sir.
sir.
Fine. But if we observe that this term is actually negative, okay, so if we want to make this term
direction ulta.
positive, right, it also means the direction is opposite. Fine. But if we want to make this term positive, we can add a minus sign before it. This term itself is a negative value, and there is a minus before it. So minus and minus will be plus, positive value, isn't it?
Yes, sir.
Yes,
Okay.
sir.
So actually this is a strategy to make the current positive. Okay. Fine. Now assume we are talking about current at time t. Now assume when time is t, then what is the charge on the capacitor? We can assume the charge on the capacitor is q. This is nothing but an assumption. Okay. When the time is t, suppose at that time the charge on the capacitor is q. Okay. Then at that particular time t, what would be the potential difference, or what would be the potential across this capacitor? It is Vc of t, right? And Vc of t equals to, we know that, q by c. Now what is the value of q at time t? At this time t, what is the value of q? It is small q, isn't
Q.
it? Small q, right?
Yes, sir.
Isn't it? So the potential difference across the capacitor will be small q by c. In the initial state, it was small q naught by c, but at time t, at a particular time t, it is small q by c. Fine. Okay. Then now what would be the potential at this node at time t? It is small q by c, isn't it?
Yes, sir.
Right. Okay. Now what would be the current at time t through this resistor R? It can be written as IT equals to what? The potential difference across resistor R, which is
Q by
what?
C by R.
Q by C by R, isn't it? So this means Q by RC, isn't it?
Yes,
It means Q by RC, right? Now we can replace IT by minus dQ by dt, isn't it? We can do it, right? Okay. Now
Yes, sir.
now what should we do? Now what can we do? Tell me. We can take this
Sir,
Q,
কিউটাকে এদিকে নিয়ে
okay, and if I take Q this side, and it will be dt by RC, isn't it? Fine. Then it would be dq by q minus dt by RC. Fine. Now we can integrate both sides. Dt by RC. or simply we can write it directly. Actually, RC is a constant term, right? And we cannot integrate constant term. We know that. Fine. Now we have to take the limit. Okay. The right side is getting integrated with respect to time, and we have to integrate the left hand side with respect to charge, right? Now, okay, let me erase this part because now we do not require it. Now let us take the limit. Okay. When t was 0, then what was the value of q? What was the charge on the capacitor?
Sir, Q naught.
Q naught.
The maximum amount of charge, it is q naught.
The Q naught chilo.
Okay, and let us denote the time with capital T. Fine. But when t equals to t, that means when time is t, what is the charge on the capacitor?
Sir, Q.
It is a small q, right?
A small q.
It is a small q. So we can take the limit in this way: 0 to t, 0 to t, and q naught to q, isn't it? Okay. Now, if you integrate this term, what will you get? The integration of dx by x is what? Log e based x. Okay, log e based x. Fine. So if you integrate dq by q, then what will you get? Log e based q with the limit. And if you integrate dt, you will get t, 0 to t, right? Okay. Now, let me erase this again. Now, what can we write? Q minus log e based q naught equals to 1 upon RC t minus 0, and it could be written as q by q naught, isn't it? Minus t by RC, right? Then q by q naught equals to what? E to the power minus t by RC, isn't it? Right? Then q equals to q naught e to the power minus t by RC, right? So this is
Yes.
the equation for the amount of charge stored on the capacitor at any time t. Okay, so we can, and of course this charge will vary over time, right? The amount of charge will vary over time. Initially there will be a lot of charge, and gradually the charge will be decreasing on the capacitor plate, right? So we can say that this charge on the capacitor plate is actually a function of time. So we can write it in this way: q is a function of time, isn't it? Is it clear?
Yes, sir.
Do you have any confusion, or do you have any question? No question.
No, sir.
So we have found out the charge stored on the capacitor plate at time t. Now we are interested in finding out the current at time t. Okay, and we know the equation for current. Okay, again let me erase. Okay, so the equation for it was what? It was dq by dt. Okay, it was dq by dt. Okay, now this time actually I do not want to consider this negative value, because we know that the current will be negative. Negative current means the direction of current is opposite, right, to the current of the charging phase. Or negative can also mean the current is getting discharged. Okay, the capacitor is getting discharged. Fine. Okay, so if we now put the value of Q, then what will you get? Q minus T by RC, isn't it? Then Q naught is equals to what? E upon R, and this is a fixed term or constant term, so we can take this out. D by dt inverse T by RC, right? Then what will you get if you differentiate this term? What will you get?
Sir, e to the power minus t by RC.
Minus T by RC, isn't it?
Yes, sir.
Right?
Yes.
Minus T by RC equals to minus 1 by RC, isn't it? Now we know that Q naught equals to what? CE minus e to the power RC minus 1 by RC. Okay, then this C and this C will cancel each other, and it can be written as E upon R multiplied by T by RC. Fine. And IT can be finally written as I naught. E upon R is what? The maximum amount of current that can pass through this circuit, right? That means the initial current, which is I naught minus T by RC.
স্যার এখানে মাইনাস সাইন লাগবে না?
Oh, sorry. Yeah, the minus sign will also be there. Okay, minus sign will be there. Fine. Okay. So this is the equation for current. Okay. Now what would be the equation for voltage? The voltage across the capacitor at any time t equals to Vc of t equals to what? Q upon C, isn't it?
Yes, sir.
Now let us plug the value of Q here. We know that Q equals to Q naught E upon T inverse RC, right? Please note down these equations. Okay, and this is C. Now Q naught equals to CE RC and C will cancel each other. So finally VCT of T will be what? E multiplied by E T upon RC, isn't it?
Yes, sir.
Yes, sir.
Right? It will happen. Okay. Do you have any confusion? No confusion, right? Okay.
No, sir.
No, sir.
That's good. That is all about the discharging phase of the capacitor. Okay. So again, the discharging phase of a capacitor has 3 states. One is initial state, another one is transient state, and the last one is what? Final state or steady state.
Steady state condition.
And we know what happens during each state. Okay, fine.
Yes, sir.
Now let us define time constant during the discharging phase of the capacitor in terms of the charge stored on the capacitor. Okay, the equation for charge is Q naught equals to Q of T equals to Q naught E inverse T by RC, isn't it? Right?
Yes, sir.
তাই না? এখন sorry, now we know that the power actually T by RC is a power of E, isn't it? Right?
Yes, sir.
And we
Yes,
know
sir.
that the power cannot have unit. Fine. Okay, so we will take the product of RC as time. we'll consider the product of R and C to be time. Okay, and that time will be known as time constant. Okay, and it is represented by tau. Fine, tau is the time constant. So we can rewrite this equation actually in this way: Q naught minus by tau, right? Now when T will be tau, what would be the value of Qt at that time? It is Q naught upon E inverse 1, isn't it? Right? And what is E inverse 1? What is E inverse 1?
Sir, 0.368.
0.368. It means what? 36.8% of Q naught, isn't it? So can you
Yes, sir.
now define time constant during the discharging phase of the capacitor in terms of charge? Can you define?
Yes, sir.
Please give me the definition. During the discharging phase of the capacitor, charge is getting reduced over time, right? Fine. So
Yes,
we
sir.
can define time constant as the amount of time during which, okay, the charge on the capacitor gets reduced to 36.8% of the maximum charge, isn't it? We can define time constant as the amount of time during which the charge on the capacitor gets reduced to 36.8% of its maximum value, isn't it? At time t, the charge on the capacitor plate will be what? 36.8% of the maximum charge, right?
Yes, sir.
So during discharging phase, time constant is defined as the amount of time during which the charge on the capacitor gets reduced to what? 36.8% of its maximum value, right? Okay, so I hope, have you understood it?
Yes, sir. Yes, sir.
Okay, fine. So now I hope you can also define time constant tau during the discharging phase of the capacitor in terms of voltage, in terms of current also, right? Fine. And
Yes, sir.
of course, surely I will give you a question from this topic in the exam. I might ask you to define tau during the discharging phase of the capacitor or the charging phase of the capacitor in terms of any of these quantities, in terms of charge, in terms of current, in terms of voltage. Fine. Okay. I even might ask you the plot this equation. Plot this equation. Okay. Plot Qt of t versus time. So can you plot this function versus time?
Yes, sir.
I hope you can, right?
Yes, sir.
Okay. You will be able to plot this function, fine. So I will not show you these types of things again. Okay. Now, actually, this is all about the discharging phase of the capacitor. Now we are going to solve some mathematical problems related to the charging phase of the capacitor and discharging phase of the capacitor, and these are very important to understand. Okay, let me ask you a question first. তোমাদের কারোর কি রোবোটিক্স নিয়ে কাজ করার ইন্টারেস্ট আছে ফিউচারে? টু এনি অফ ইউ ওয়ান্ট টু বি রোবোটিক্স ইঞ্জিনিয়ার ইন ফিউচার?
স্যার সিএসসি থেকে কি ওইদিকে যাওয়া যায়, মানে হচ্ছে রোবোটিক্স এর জন্য
তার
তো
ইচ্ছা আছে।
কি আছে?
ইচ্ছা
Why
আছে
not?
স্যার ইচ্ছা আছে। ইচ্ছা আছে
সিএসসি
স্যার।
থেকে
জি স্যার।
সিএসসি থেকে তুমি কেন রোবোটিক্সে যেতে পারবে না?
স্যার যেমন হচ্ছে ঢাকা ইউনিভার্সিটিতে আলাদা হচ্ছে রোবোটিক্স এন্ড মেকাট্রনিক্স নামে আলাদা একটা ডিপার্টমেন্ট আছে, তাই বললাম
না,
আর কি জানার জন্য।
আমি যতদূর জানি যে হচ্ছে আমাদের এখানে রোবোটিক্স এভাবে পড়ানো হতো না, বাট আমার এক ফ্রেন্ড ছিল চুয়েটে পড়তো, ওদের সিএসসি তে তো রোবোটিক্স পড়ানো হতো। ইনফ্যাক্ট এখন আমাদের এখানে রোবোটিক্স নামে একটা সাবজেক্ট আছে আমাদের ডিপার্টমেন্টে। ওকে, রোবোটিক্স এর জন্য তোমার যেটা লাগবে সেটা হচ্ছে যে প্রোগ্রামিং নলেজ। রোবটকে যাতে আমি কন্ট্রোল করতে পারি তার জন্য তোমার ভালো প্রোগ্রামিং নলেজ দরকার। সাথে সাথে কি দরকার, তোমার হচ্ছে হার্ডওয়্যার নলেজটা দরকার হবে। এবং কেউ যদি রোবোটিক্স নিয়ে কাজ করতে চাও ফিউচারে, তার জন্য এই ইলেকট্রিক্যাল সার্কিট, ইলেকট্রনিক সার্কিট, এই কোর্সগুলোর খুব ভালো বেসিক থাকতে হবে। ওকে, অ্যান্ড রোবোটিক্স ইঞ্জিনিয়ারিং ইজ ওয়ান অফ দ্য highly demanded profession in the world. Okay,
ইয়েস স্যার।
fine. If you are interested in working game industry, then you must be a robotics engineer. Fine. Okay.
ইয়েস স্যার।
For robotics, you will need both the knowledge of CSE and hardware knowledge also. Okay. সো যারা আসলে রোবোটিক্স নিয়ে ফিউচারে কাজ করতে চাও তারা এই কোর্সগুলো খুব ভালো মানে খুব একটা ভালো বেসিক আইডিয়া রাখার ট্রাই করবা, এটা হেল্প হবে ইন দ্য ফিউচার। and it's a very demandable field. Okay,
স্যার আমার একটা মানে
লাইক
ইনফরমেশন
হচ্ছে
জানার
এখন
ছিল।
কম্পিউটার সায়েন্সের ডিমান্ডেবল একটা ফিল্ড হচ্ছে যে ডেটা সায়েন্টিস্ট। ওকে, ডেটা সায়েন্টিস্ট জবে হচ্ছে খুবই ডিমান্ডেবল, যেমন হচ্ছে ক্লাউড কম্পিউটিং, এগুলো হচ্ছে খুবই ডিমান্ডেবল। ওকে, বলো, গো অন উইথ দ্য কোশ্চেন।
স্যার আমাদের এই যে সিএস কোর্সে কি মানে ফিউচারে মাইক্রো কন্ট্রোলার রিলেটেড কিছু পড়ানো হবে?
Of course, and microcontroller will be required for robotics engineering. Fine. Even I took one course known as computer peripherals and interfacing. Okay, which is actually basically the introduction to these kinds of things. Okay, robotics engineering.
জি স্যার।
Actually, this is not totally related to the robotics engineering, but in that course I taught about these kinds of thing. Okay,
জি স্যার।
microcontroller. Fine.
স্যার কেউ যদি স্যার কম্পিটিটিভ প্রোগ্রামিং এ আগ্রহী থাকে সেক্ষেত্রে কি রোবোটিক্সটা মানে ওই দিকে যাওয়াটা উচিত হবে কিনা? যদি
তোমাকে আগে বুঝতে হবে যে কম্পিটিটিভ প্রোগ্রামিং দিয়ে তুমি কি করতে পারবা। কম্পিটিটিভ প্রোগ্রামিং কিন্তু কোনো তোমার হচ্ছে এটা একটা টুল। ওকে, কম্পিটিটিভ প্রোগ্রামিং তোমাকে কি বানাবে, খুব ভালো প্রবলেম সলভার বানাবে, রাইট?
ইয়েস স্যার।
যেটা হচ্ছে এই নলেজটা তোমার ফিউচারে কোনো একটা অ্যাপ্লিকেবল ফিল্ডে খুব ভালো কাজে লাগবে। ফাইন।
ইয়েস স্যার।
লাইক তুমি যখন কম্পিটিটিভ প্রোগ্রামিং করে গুগলে জব পাবা, তার মানে এই না ওরা তোমাকে কম্পিটিটিভ প্রোগ্রামিং করতে দিবে সবসময়। দেখা যাচ্ছে তুমি খুব ভালো প্রোগ্রামার গুগলে জব পাইছো, তোমার প্রোগ্রামিং করা লাগতেছে 10%, 30%, রিমেনিং 70% হচ্ছে অন্যান্য থিংস। এন্ড দিস ইজ ট্রু। ওকে, দিস ইজ ট্রু।
ইয়েস
ফাইন।
ইয়েস স্যার।
ঠিক আছে, এই জন্য হচ্ছে যে তোমার প্রোগ্রামিংটা হচ্ছে কম্পিটিটিভ প্রোগ্রামিংটা হচ্ছে খুব ভালো একটা ওয়ে ফর লার্নিং প্রোগ্রামিং অর লার্নিং প্রবলেম সলভিং। ফাইন, এটা হচ্ছে তোমার একটা টুল যেটা তুমি পরবর্তীতে বিভিন্ন ফিল্ডে অ্যাপ্লাই করতে পারবে। এবং দিস ইজ দ্য হার্ডেস্ট পার্ট অ্যাকচুয়ালি, দ্যাটস ওয়াই ইউ শুড গিভ মোর টাইম অন কম্পিটিটিভ প্রোগ্রামিং অর অন প্রবলেম সলভিং। ওকে, that's my view. I think other can differ also. Okay, now let us solve some mathematical problem. তোমরা হচ্ছে কোনো কোর্সকেই মানে অবহেলার সাথে দেখবা না আর কি, তোমার প্রত্যেকটা কোর্সেরই অ্যাপ্লিকেশন আছে ফিউচারে, ঠিক আছে? এবং এগুলো দরকার হবে তুমি যদি বড় কোনো জায়গায় যেতে চাও আর কি। ওকে, Now we have given a question like okay. Now we are in the question, we are given a network configuration, fine, and we are required to find out I1 and I2 at t equals to 0 and at steady state. Okay, can you solve this problem? Can you?
Yes, sir.
Yes, sir.
That's great. That's great actually. Maybe some of you can solve the problem, or maybe all of you, but yet I will solve this problem for you. Okay. At t equals to 0, we know that here is a capacitor whose capacitance is 10 microfarad. And we know that at t equals to 0, that means in the initial state, the capacitor acts as a short circuit, right?
Yes, sir.
So we can redraw the circuit in this way. This is 2 ohm, this is 3 ohm, and this part will be short circuit. Capacitor will be replaced by short circuit. 20 volt. This is I1, this is I2. Okay. Now what would be the value of I1? বলো তো কিভাবে বের করতে হবে? How can we find out I1? At first we have to find out the total current, source current.
পুরোটা আগে বের করতে হবে।
Right? At first you have to find out the source current. So source current IS equals to what? 20 upon
2 parallel
total,
3.
the total
parallel
resistance, that
3.
means 2 parallel 3, isn't it?
Yes, sir.
20 upon the total resistance of this circuit seen from these two terminals of the battery. Okay. Then 2 and 3 are in parallel, so that their total resistance can be written as 2 parallel 3. Okay. So what is 2 parallel 3? This is
The
nothing but
1.2.
2 multiplied by
1.2.
3 by 2 plus 3, right?
6.5, 6 by 5.
So what will be the value of IS? What is
Sir,
the value of IS? Tell me.
50 by 3.
Sorry,
50 by 3.
50 by 3. I hope this is correct.
16.67.
Yes, sir.
Okay, 50 by 3 is okay. 3 আর 2 5 6 9 yeah, it is correct. Now what would be the value of I1? Source current, right? Source current multiplied by what?
So 3 by
3 by
2 plus 3.
By
2 plus 3,
2 plus. Sir,
right?
2
3
and
by 2 plus
3
3. Okay.
parallel.
So okay. So
Yes, sir.
3 by 6. This will cancel each other. And what would be this value? It is 6.33 something. Okay, isn't it? Ampere. Okay. What would be the value of I2?
Sir, এটা 10 ampere হবে না স্যার? I want
Sir, 10 ampere হবে answer.
10 ampere.
The 2
Why?
plus 3
10
5
amperes
হবে.
sir হবে।
5.
Oh,
2 plus
sorry,
3
2
10.
plus 3
5.
equals to 5, right? এই জন্যই হচ্ছে বয়স হয়ে গেলে সমস্যা আর কি, বৃদ্ধ টাইপের মানুষের। So what would be the value of I2?
The 20 by 3 ampere.
No, tell me the equation. I'd be happy.
So 2 by 2 plus 3.
2 divided by 2 plus 3.
2 divided by 2 plus 3, right?
Yes, sir.
And you can find out the value, right?
The 20 by 3.
Okay. আচ্ছা, তোমরা পরের ম্যাথটা সলভ করো এবং আমার জন্য কিছুক্ষণ ওয়েট করো, ওকে? 5 মিনিটসের মতো, ঠিক আছে?